Okay, so I apologize for not getting a little bit more done in class, but I just want one of the things on the test is going to be given a general form equation, which would be, you know, something like this, of a conic. You should be able to graph, obviously, an ellipse, a circle, a parabola, and a hyperbola. But I could give you some of the degenerate conics, and if you remember, the three degenerate conics were a point, two intersecting lines, and a line. So I just want to show you what these constants A, B, C, D, E, and F, kind of how they change the conic. So right now I have, you know, these given values A, B, C, D, E, F. Right now B is equal to 0. B is the one that I kind of wanted you to be aware of, although I won't really test on it, this XY term. So as you change the C value, oh no, I gotta get my selector tool. As you change the C value, that's the coefficient of the y squared term right here. You can see that it kind of changes for the ellipse. It'll make it kind of taller and shorter. If you change the A value, it's going to make the horizontal distance wider and shorter, more elongated, or more narrow. If your A and B are exactly, your A and your C are exactly the same, then you get a circle. If the A and the B are A and the C are exactly the same, then you have a circle. Now, on some of the practice tests, there's sections where it says identify the conic, and it lists like 8 of them. And that's what you're supposed to do. You say, well, if A and C are both positive and both the same, then you have a circle. If they're both positive, but one is longer, bigger, or smaller than the other, then you have an ellipse. And if one of those, like that A value, hops over to a negative, it'll actually create a hyperbola. So if A and C are opposite signs, it'll create a hyperbola, and you can do that either way. If you make the C negative, then it goes sideways. If you make the A negative, then it goes up and down. So if they're opposite values, you get a hyperbola. So then what does the coefficient of the x term, this D value, do? Well, what the D value is going to do is, that's what kind of shifts it off the center. Whenever you have a x value, that's when you got to complete the square, and it kind of shifts it off. But it doesn't just shift it off, it also changes the size, because whenever you complete the square and you add that constant, it also changes that kind of that F value there. So that's going to shift it left and right and change the size kind of horizontally. And then E is going to obviously kind of shift it up and down, and also again kind of change the size. The F value straight up changes the size of it. So whenever it's really big, that's the F constant. Now, whenever that F value whenever it kind of goes to one specific value, you can kind of see this ellipse collapse to a single point. And that's one of the degenerate conics that you're going to be responsible for on the test. And I'll show you what it looks like whenever you graph it, but that's kind of visually what it would look like. If you start with a hyperbola, let's move some of this stuff around a little bit. If you start with a hyperbola, again, that F kind of changes this, and whenever that F hops over to the opposite sign, it kind of changes which way it opens, because it changes the plus and minus. But again, if F is one very specific value, right where it switches between the two, that's going to be that degenerate conic that is two intersecting lines. Again, you don't have to, to really know this, I guess, but if I give you a general conic, a conic in general form that has exactly the right F value and it's two intersecting lines, you got to graph the two intersecting lines, okay? The last thing I wanted to show you is what that disappeared there. What that XY term does. This XY term here is kind of a special term. It's one that we've never really looked at before, and it's a little beyond the scope of this course. But what that XY term does, is it's going to change, it's going to kind of elongate, it basically rotates your conic. If you have a hyperbola, it'll kind of rotate it this way. In fact, one hyperbola that you guys probably didn't even know we had studied before, but we did, was the conic y equals 1 over x. We studied this as a base graph, but y equals x is actually a hyperbola. So if I want to get y equals x, in general form it would look like xy equals 1, right? If I solve this, if I just multiply by x, so what I need to do is I kind of need to zero out everything except for the xy term. So zero that out. It's not going to look right away, but if I zero all of these values out and then just make my b equal to 1, that is that hyperbola. All right, so future videos here, I'm going to show you how to, given a conic in general form, one of the degenerate conics, I'll show you guys how to graph it, okay? Stop.